common issue when designing LDOs into an application is selecting the correct output capacitor. In today's video, we will explore different considerations when selecting an output capacitor and how it may affect your LDO. Let's begin. First, let us define the differences between capacitor and capacitance. A capacitor is a device that uses a pair of conductors separated by an insulator in order to store electric charge. The most common capacitors are made of aluminum, tantalum, or ceramic. Each of these materials has their own pros and cons, as listed in this table. I generally recommend ceramic capacitors because of their minimal variation in capacitance value and their low cost. Capacitance is the ability to store an electric charge and is a numerical value, as seen on the right. In an ideal world, the value written on a capacitor would be exactly the same as the amount of capacitance it provides. However, we do not live in a world of ideal components. There are three main reasons why the capacitance of a capacitor isn't always what it says on the label. Derating due to being biased with a DC voltage, derating due to changes in temperature, and manufacturing tolerances. This one is specifically called out in the specs of the capacitor and is usually plus or minus 10 to 20%. For the real world example later, I'll be using plus or minus 20%. I'll mainly also just go over the first two in this video. The most common source of derating in capacitors occurs when a DC voltage is applied to a capacitor. This creates an electric field which locks some of the atomic dipoles in place. These locked dipoles do not react to AC voltage, which is why the effective capacitance decreases. Now looking at this graph, you can see that the size and thickness of the capacitor also affects the capacitance. The same voltage applied across a thicker dielectric will result in a lower electric field, which will lock less dipoles and increase the effective capacitance. Like all electronics, capacitors have a temperature rating over which their performance is specified. This temperature derating can commonly be found underneath the numerical value of the capacitor. The table shown is a capacitor decoder where you can decipher the meaning of the three characters. Since the majority of LDO junction temperatures are usually specified from -40°C to 125°C, we generally recommend X5R or X7R capacitors. As shown in this graph, temperature degrades the capacitance much less than the DC bias, which can reduce the capacitance by 90%. In this example, we'll be looking at a typical LDO application, which is to take an input voltage from 3.6 volts battery and drop it to power a microcontroller at about 1.8 volts. In this example, I'll be using a 10 microfarad X7R ceramic capacitor in a 0603 package. The 0603 package refers to the dimensions of the capacitor. I'll be taking the worst case scenario for each case. First, we must consider the DC bias derating. By using the chart provided by the manufacturer of the DC bias characteristics of a capacitor, as shown on the right, the output capacitor will see a DC voltage of 1.8 volts, which means the resulting capacitance will now be 7 microfarads. Second, we must consider the thermal degrading found by using the ceramic capacitor code table. We can see that the R suffix refers to another 15% drop in capacitance value over -55°C to 125°C, bringing the new total to 5.5 microfarads. Lastly, we should take into consideration the manufacturing tolerance of plus or minus 20%, as I mentioned earlier. The final capacitance value will be 3.5 microfarads. As you can see, a 10 microfarad capacitor has a true value of 3.5 microfarads when put into these conditions. The capacitance value has degraded about 65% of the nominal value. Obviously, not all these conditions would apply, but it is important to know the dynamic range of capacitance values that a capacitor can provide for your application. That's all for today's video. Be sure to check out our online portal at ti.com/LDO for the latest information. Stop by our training and support homepage to watch the latest LDO basics videos, or head over to our E2E forum and read what our experts have to say about LDOs. We look forward to seeing you in our next LDO basics videos. Have a great day.